Hello once again. Welcome to Chapter 7, Pesticides in the Environment. So this is a practice run for some asynchronous CEU modules that will be produced here in the near future for professional pesticide applicators. My goal with these is to get this material out to the public so you can understand more about pesticides and pesticide applications, but also to give me a chance to practice these and see how the timing goes and how the presentation flows. Please remember that these slides are for professional pesticide applicators, so everything you hear may not exactly fit your life. However, I do welcome any questions or comments. Just leave them in the thread below, and I will do my best to respond to all of them. These materials come from the National Pesticide Safety Education Core Manual. The page numbers that you will see during the presentation are the pages in the manual you would want to refer to if you had questions about topics that are covered or wanted more information. If you are looking for a copy of the core manual, you can go to the USU PSEP Pesticide Safety Education Program Facebook page, and in a posted comment posted in a pinned post, you will find a link to the National Core Manual, a free downloadable version of it. All right, so Chapter 7, Pesticides in the Environment. First thing to cover is, what is the environment? The environment is everything around us. It includes all the biotic factors, so the living things, the plants, animals, microorganisms, and the humans. It also includes the abiotic factors, the air, the soil, the water, the rocks, etc. Factors even also. Additionally, the environment exists inside and outside, so all of these things make up the environment. There is a law of conservation, which basically states that we live in a bubble. Matter does not disappear, it simply changes form and then continues to exist. Couple of important things to understand about pesticides and to help us facilitate this discussion of pesticide movement are pesticide characteristics. Our first characteristic is adsorption. That's adsorption with a D, not absorption with a B. Adsorption is the process of something binding to soil particles. So if you have a pesticide that is highly adsorptive, it is going to strongly bind to soil particles or organic matter. Second one is solubility, which is just a fancy word for how well something dissolves in a solvent. In most cases, we're talking about water. So if you have a highly soluble pesticide, it will readily dissolve and move in water. And we have volatility. Volatility is simply the tendency of something to turn from a liquid or solid to a vapor gas. So if something has a high volatility, it has a high probability of going into a gas form from its liquid or solid form. And then our final pesticide characteristic is persistence, and that's just what it sounds like. How long the active ingredient will remain present and active before being broken down or degraded by different factors. This is typically measured in half-life. Persistence doesn't affect the ability of the pesticide to move in the environment, but it does play into whether or not that pesticide can be a problem when it reaches the next location. So if we look at the fate of pesticides in the environment and how they are transported, there's lots of different ways it can go on. First up, if you're spraying an herbicide, the uptake of it by the plant. That's your goal. You want this to go into the plant. So plant uptake, if it's an insecticide, insect uptake. So we have uptake. Then we have off-target movements that can happen through various different types of drift. We have particle drift, spray drift, and vapor drift. We will look at all of these individually here in the near future. And then we have movement of pesticides in water. So we have runoff and leaching as our next two topics. Runoff is the movement of pesticides in water across the surface of soils, whereas leaching is the movement of pesticides in water below the surface of soil. Leaching generally thought of as a downward movement, but it can also be horizontal. And then there's adsorption, which we just talked about. So if a pesticide is highly adsorptive, it will bind to those soil particles and not move as readily. If you have enough water, it can move even with the soil particles. And then our last potential fate of these guys is degradation. They can be broken down through photodegradation by the sun. They can be broken down by microbial degradation in the soil. There are actually organisms out there that eat pesticides and will break them down. And then there's chemical degradation, just the chemical breakdown of the pesticide. In most cases, degradation leads to a less toxic version. Preventing pesticide drift. So what is drift? Well, drift is just that airborne movement of particles or water vapor to a non-target area. There's different types of drift. There's spray, vapor, and particle drift, which we'll look at individually here on the next few slides. And this drift can cause damage or contaminate sensitive crops, bees. It can pose health risks to humans and animals, and it can contaminate soil and water in adjacent areas. So managing drift is a very important thing when you're doing a pesticide application. Our first type of drift is spray drift. It sounds just like what it is. It's the drift that occurs while you are spraying the pesticide. And there's an indirect relationship between viscosity, droplet size, and drift potential. The more viscous or thick the solution is, or the bigger the droplet size, the less potential you have for drift. More viscosity means that your liquid sticks together more, which leads to larger droplets, and larger droplets have more mass, so they fall faster and have a lower potential for drift. In some instances, an application actually will require drift. And the main one that comes to mind with this is aerial applications if there's a light breeze. Sometimes the aerial applicator will come down slightly upwind of what his target is and release the product and allow it to drift downwind and land on his target. Again, droplet size affects how much drift occurs. Bigger droplets fall faster, so they have less likelihood of drift. Drift can occur very frequently with very small droplet size, and it's affected by wind direction and speed. There's an interesting phenomenon in pesticide applications where very, very low winds are often indicative of a temperature inversion, which can actually increase the potential for drift. Excuse me. Vapor drift. This most often occurs with high air temperatures. Many products will have mandated do not apply above certain temperatures in their labeling. It's the movement, vapor drift is just that movement of a pesticide as a gaseous vapor. So if you come out and you apply the pesticide early in the day on what is going to be a hot day, the temperatures have the potential of getting up to the point where the pesticide will volatilize, and then it will just be carried off in the air, often flowing very much like a river in the air, going downhill, downstream, so to speak, in an air current. Different pesticide formulations have different volatility. You can get low volatility pesticides, which will reduce the likelihood of your volatilization. And then there are adjuvants you can add to reduce volatility. Adjuvants often are used to increase the viscosity of the pesticide application, which will reduce both spray drift and vapor drift. Finally, we have particle drift, and that's just the movement of solid particles after an application. So granular or dust formulations, or even liquid formulations that have absorbed to soil particles. As you can see in the picture to the left, when tilling a field, you have a potential for particle drift. It's our hope, and it is the plan of the field manager to do this tilling well after the pesticides have become inactive, so that what dust does float away isn't carrying active pesticides. Particle drift can occur with moving equipment. If you are in a field working, it's advised to close vents, windows, and intake systems to prevent indoor contamination. If you live near a farm field, this is also a good move to reduce your indoor contamination. Moving on to water contamination. Water contamination has several factors that play into it. The soil properties play in, and whether or not there's organic matter. Soil properties, the texture and the structure of the soil becomes very important. The proportions of sand versus silt or clay will affect how easily water can move through a soil. Very, very sandy soils are often very porous and allow movement of water very easily, while soils heavy in clay are often much less porous and the water doesn't move quite as well. And then, of course, the shape or arrangement of the soil particles will also come into play. The presence of organic matter, so decaying plant matter, higher organic content increases the ability to hold water and absorb those pesticides. So more organic matter will hold pesticides more strongly, and that leads to less leaching. And then, of course, the depth to groundwater or geology plays in. The permeability, the more space between particles, the more likely it is to permeate through the soil. The addition of clay, again, will slow that down. So knowing the soil structures, what kind of organic matter, and your geology will all help you avoid contaminating water when making applications. Surface water contamination. Often surface water contamination occurs by pesticides moving with runoff or eroded sediment. This can be affected by vegetation cover, which of course will lead to more organic matter, which can also reduce the amount of water movement. The soil characteristics, as we just discussed, will change those rates. And then the slope of the land that you apply to will obviously play into it too. The pesticide's characteristics are important here. Again, a highly soluble pesticide will easily be taken up by water and then move with the water. So the volume and rate of the water moving will also play in. So if you apply a pesticide that's highly soluble and then there's a big water event that follows it, you could have a lot of movement of pesticides off your target area into surface waters. Groundwater, different things that affect the possibility for contaminating groundwater include underground cracks and pores, the saturation zone influence, the saturation zone just being that portion of the soil where it is saturated with water. Once a pesticide reaches that, especially a highly soluble pesticide, it is free to move in water much more. The depth of the water table plays in. What kind of land use is occurring in the area can help or can have an effect on contamination of groundwater. And then the soil characteristics, as we discussed just a little bit ago, and those pesticide characteristics, again, once play into whether or not that will readily move into groundwater. So if we look at these comparisons, the question is which type pesticide is more likely to move into ground or surface water. Would it be a highly soluble or a non-soluble pesticide? It would be the highly soluble. If you have soil or low soil adsorption potential versus high soil adsorption potential, the one with the low soil adsorption potential has a higher probability of moving into water because it's not binding strongly to that soil. And then the persistence versus the non-persistence. The persistent pesticide is the one we're worried about. Once again, persistence doesn't affect the ability of the pesticide to move, but it does affect whether or not that pesticide will have an effect when it reaches the next location. What can you do to help prevent water contamination? Well, understanding the characteristics of the pesticide and the application area, as we just discussed, are really important to do that. Also, using integrated pest management. So with IPM, you only apply your pesticides when necessary. Once you've tried other control methods and they've proved ineffective, then you use a pesticide. You also can select that least toxic product, but most effective. So least toxic, but will do the job. Make sure that your equipment is calibrated correctly and you're putting down the appropriate mounts, and then use spot treatments where appropriate. Additionally, if you identify those vulnerable areas where you have sandy soil, streams and wells, if you have water bodies nearby, and you can also help to reduce the probability of erosion by using berms or terraces, and then time your application with weather and irrigation events in mind. Keeping these in mind will help you reduce your chances of preventing water contamination and will also increase the efficacy of your pesticide application because your chemistry will stay where you want it. All right, that's it for this guy. Thank you all very much for your time and have a nice day.